All right, so we have this question presented before us. It says express express the force F shown in the figure below as a Cartesian vector. So what they want us to do is they want us to express this force that is given here in the IJK notation. And how do you do that? It's very simple. It's not something that is hard to understand or to do. So let's quickly do it. How do we start and what do we start with? So first of all, we have to check what we have been given and what we have not been given. So we have been given beta. So beta has been given to be what? 60 degrees. Then we've also been given gamma to be what? To be 45 degrees. Have we been given alpha? Alpha is not given. So we will start first by finding the things that have not been given. And alpha is not given here. So we can first start by finding alpha. How do we find alpha and where do we get alpha? From the cosine, we're going to get alpha from the direction cosines. So the direction cosine angle formula, we know it to be cos alpha plus cos beta plus cos gamma is equal to 1. So this has to be squared. So alpha is not given. So we can make cos squared alpha as the subject. So we have cos squared alpha being equal to 1 minus cos squared what? Beta. So what is our beta? 60. So we can replace our 60 there. Then 60 degrees, of course. Then we have minus cos squared gamma is what? 45 degrees. So once we have this, it's now easy for us to find the answer. So we have cos squared alpha being equal to 1 minus. So we have this part here, which is cos 60. What is cos 60? So cos 60 is simply just 0.5. So this is just the same as saying 0.5 what? Squared. Then we have cos 45. Cos 45 is just the same as the root of 2 over 2, which is simply just 0.707. That is the shortest way you can write that. Yeah, in decimal form. But if you want, you can write it as the root of okay, let's do this. I think that is actually even the best. Let me write it in fraction form. So this is just going to be the root of 2 over 2 squared. So when we simplify this, we're going to have 1 minus 0.5 times 0.5. Yeah, so 0.5 squared gives us what? 0.25. So we have 0.25 there. Then we have minus the root of 2 squared gives us 2. The root of 2 is 4. So this one is just the same as 1 over 2, which is just the same as 0.5. Then when you do the subtraction there, you get 0.25 as the solution. So you get 0.25 as the solution. Then when you do the square root this side and this side, you get your solution to be what? Let me write it in. So we're going to have cos alpha being equal to plus or minus 0.5. Yeah, of course, this one we need to put plus or minus there. So plus or minus 0.5. So the first angle that we're going to get is alpha, or let me say cos alpha is equal to 0.5. And we also have cos alpha being equal to negative 0.5. So alpha is equal to cos inverse of 0.5. So alpha gives us what? 60 degrees. And then we also find alpha this side. Alpha is equal to cos inverse of negative 0.5, which gives us what? 120 degrees. That is in the second quadrant there. Okay, so this is what we have. So now we can just, by inspection or by reasoning, we can see that the angle or the quadrant or the region where this, where this force is simply in the first quadrant. Or if you don't want to use the quadrant, you can see that it's bending towards it's bending towards the axis, which is the x-axis. Hence, this angle can't be 120. It can only be 60 degrees. Yeah, or let me just say it's in the first quadrant. So this angle can't be 120 to only be 60. So meaning this one is not part of our solution. So we're just going to go with 60 degrees as our solution. And then we have now finally found what was missing. So we can simply plug it into the cosine direction, cosine angles, and now we equate it to what? We equate it to the Cartesian. Okay, let me explain. Let me write what I'm trying to explain. Okay, so the first thing that we do is we find the unit vector, because we know that the unit vector of any given force is the one that is directly related to its cosine, to its direction cosines. So let us write the unit vector in the direction of 200, in the direction of F. So the unit vector in the direction of F is simply just going to be what? So this will be 200 cos, this will be 200 cos what? Cos alpha. So 200 cos alpha, my alpha is what? 60 degrees. Then we say plus 200 cos, the beta that we have here is what? The beta is also 60. Then we say plus cos gamma, the gamma that we have here is 45 degrees. So when you find these, you're going to have the unit vector in the direction of F as, so when you find the first part here will give you 100, because 200 times 0.5 will give you 100. So you put I, and then the second part here will also give you 100 J, and then this one will give you, we say 200 times, so we say cos 45 times 200, which gives us 141. So we have positive 141, 141.4 K. So having done this, we can now, so we can now, listen, the question is asking us to express F in the Cartesian vector. I think this is the final answer. Yeah, I thought maybe we were supposed to relate it with something else, but I think this is the final answer, because it has, oh, it's F in what's this? As a Cartesian vector. So this is the unit vector in the direction of what? Of F. Yeah, so what we found is just the unit vector. Okay. So let's take a look at the solution. Yeah, so this is exactly what I was saying. So this is the unit vector. So if they ask you to express any given force, they ask you to express any given force as a Cartesian vector, the most important thing that you first have to look at is to, the most important thing that you need first to look for is you first need to look for the you first need to look for the direction cosine angles. And then from there, you can now just multiply the force with its corresponding direction cosine angle. Yeah, so for instance, the first term there will go with cos alpha, then you multiply it with F. Then the second term will go with cos beta, we multiply it with F. The third term there will go with cos gamma, we multiply it with F as well. So this is what you are going to get at this, as the solution. All right, let's quickly move on to the next question. So the other question is this one, which says determine the magnitude and coordinate and the coordinate direction angles of the resultant force acting on the ring. So this one is simple. Remember what I said, to find the resultant force of any vector in Cartesian, you just have to add its corresponding what? Its corresponding components to find the summation of F, the forces in the X, you say I, plus the summation of the forces in the Y, this will be J, plus the summation of the forces in the Z, then that will be K. So this is what we're going to do. So to find the resultant force is going to be given by, you add, so we have 50 in the X there. Do we have the X component of this force? We don't have. So the first one here will just be 50. So we're going to have 50I. And then we have negative 100. So I'm going to say plus, open brackets, negative 100. Then we have J there, negative 100J, we have 60J there. So we say plus 60, then we say J. Then in the last one, we have 180 there. So we can say plus 100 plus 80J. This will be K. Then we can add up everything. So when you add up everything, we're going to get 50I plus, when you add this, you're going to get negative. So we say minus here. So we're going to get negative 60. So we get negative 60. Oh, sorry, negative 40. Negative 40J. Then when you add 180, you get 180K. So having done this, the next thing that you need to do is, the next thing that you need to do is, okay, this is the resultant that we have found. And then, okay, you've been asked to find the resultant force acting on the ring. So this is the resultant force. Now to find the scalar, okay, this is the resultant force in its Cartesian representation. But representing this in its scalar form, you say FR will be equal to the square root of, we have 50 there squared, and then we have plus negative 40 squared plus 180 squared. And when you do the squaring there, you have 50 squared, then plus 40 squared, then you have plus 180 squared. Then you find the square root of the answer. You're going to get the solution as 191.04. So this is going to be your force. Oh, this is in pounds. So the units there that we have is in pounds. So you can just write pounds, not Newton. So this is the resultant vector. This is the resultant force. So now we've been asked to find the direction angles as well. So how do we find the direction angles? It's very simple. Remember, the direction angles come from the unit vector, and then the unit vector should be in the direction of this resultant force. So this is going to be the resultant force over the magnitude of the resultant force, which tells us that we have to divide the resultant force, which is 50I minus 40J plus 180 Okay, you divide it by the resultant, which is 191.04. So what this means is that we're going to divide everything on the numerator there by 191. So if we divide 50 by 191, we're getting 0.262. So we get 0.262 I. And then we divide negative 40. So we divide negative 40 by 191.04. I'm getting 0.209. So we're getting negative 0.209 J. And then we divide 180 by 191.04. So we're getting 0.942. So we're getting plus 0.942 and K there. So after finding these values, the next thing that you need to find is the direction cosine angles. So the next thing that you need to find is are the direction cosine angles, because that's what we've been asked to find in the question. And how do you find that? So remember, if you have any unit vector, that unit vector, if written in terms of direction cosines, that can also be written, the unit vector in the direction of this resultant force can also be written as cos alpha I plus cos beta j plus cos gamma k. So which implies that this would directly correspond to that, this would directly correspond to that, and then as usual. And then so we do the same. So what this means is that I'm going to equate cos alpha to 0.262. Then I'll also equate cos beta to negative 0.209. Then I'm also going to equate cos gamma to 0.942. So we find alpha by finding the cos inverse of 0.262. So alpha becomes so cos inverse of 0.262 rather. So 262. So we have 74.8 degrees. That is our first direction cosine angle. And then to find beta, we say cos inverse of 0.209. Of course, there's a negative this side because there's a negative there. So we say cos inverse of negative 0.209. So we're getting 102.1. So our beta becomes 102.1. 102.1. So gamma is also found in the same way. We say cos inverse of 0.9. This one, 0.942. 942. So our gamma becomes, so we say cos inverse of 0.942, which is 19.6. 19.6 degrees. So we have managed to find the magnitude of the resultant force, which is this one, and also the direction angles that we were asked to find. So we have found 74.8, 102.1, and 19.6 degrees. Do we have any questions on how to find these things? So it's just a matter of applying the formulas that I showed you. So I said all the things that we are doing are just the same as what we did in the previous lecture slides. The only difference is that whatever that we are going to be doing from now, it will involve both 2-dimension and 3-dimension. 3-dimension planes. Yeah, so we'll no longer just restrict ourselves to 2-dimension. We'll be dealing with both 2 and 3-dimension. All right, so since you don't have questions, I'm going to send an exercise in the group immediately after ending this session. So the questions that I'm going to send, make sure that you solve them and then submit them before we have our next statics lesson. Okay, see you in the next lesson. Shalom.